When we look at the effects of calorie restriction on the body, one of the most fascinating and powerful processes that gets triggered is autophagy. This word literally means a self-eating, but in reality, it is your body's built-in recycling program. The average person never really taps into this process because they are constantly eating, constantly stimulating insulin, and never giving the body a break. When food intake drops and calories are restricted, the body recognizes that nutrients are scarce and immediately flips a switch to conserve resources. Rather than allowing damaged proteins, old mitochondria, and cellular debris to accumulate, the body begins breaking these down and reusing their components to build new, healthier parts. This is a profound shift because one of the main drivers of aging is the buildup of damaged cellular material that slows down repair and accelerates dysfunction. By activating autophagy, calorie restriction clears away that damage and helps restore cells to a more youthful state. This process also has direct effects on mitochondria, the tiny energy factories inside your cells. Over time, mitochondria get damaged through oxidative stress and the constant burden of producing energy in an environment filled with sugar, toxins, and inflammation. Damaged mitochondria not only produce less energy, but also leak free radicals, which accelerate aging. Through autophagy, the body removes these weak mitochondria and stimulates the creation of new ones, which are more efficient and less damaging. This process, known as mitophagy, is a critical part of staying youthful because it ensures that your cells are powered by fresh, functional energy producers rather than broken, worn-out ones. More efficient mitochondria translate into higher energy, sharper mental clarity, better physical performance, and reduced risk of age-related diseases. Another way autophagy slows aging is through reducing the burden of misfolded proteins. These proteins, when they accumulate, can cause significant cellular dysfunction. Conditions like Alzheimer's, Parkinson's, and other neurodegenerative diseases have strong links to the buildup of damaged proteins in the brain. When calorie restriction is applied, autophagy is activated, and these misfolded proteins get broken down and recycled. This doesn't just happen in the brain, but throughout the body, in muscles, liver, and even skin cells. By cleaning out these damaged materials, the body essentially performs a deep detox at the cellular level, one that no external cleanse or supplement could replicate. This is why people who practice intermittent fasting or calorie restriction often report improved focus, mental sharpness, and even clearer skin because their body is literally renewing itself from the inside out. On top of that, the activation of autophagy during calorie restriction directly reduces inflammation. When the body is overloaded with damaged cells, it creates constant low-grade inflammation, which is one of the hallmarks of aging. Inflammation damages tissues, increases the risk of chronic diseases, and accelerates the breakdown of collagen and elastin in the skin. By clearing out old and dysfunctional components, autophagy lowers the inflammatory load, allowing tissues to heal and maintain their structure. Less inflammation means less damage over time, which directly slows down the aging process both internally and externally. It is important to understand that autophagy does not happen when the body is constantly digesting and insulin levels are high, too. It requires a state of nutrient scarcity, which is why calorie restriction is such a strong trigger. In modern society, where food is abundant and meals are consumed every few hours, most people never enter this repair state. They are stuck in constant growth and storage mode, which accelerates aging. When calories are reduced, the body is forced to prioritize maintenance over growth, which is actually a survival mechanism honed through evolution. In times of scarcity, the body becomes more efficient, repairs itself, and increases resilience so that it can survive until food becomes available again. In essence, autophagy is the body's way of upgrading itself during periods of fasting or restriction. This cellular recycling mechanism also enhances immune function. Old damaged immune cells are cleared away, making room for new, highly functional ones. This means your body becomes better at fighting off infections and preventing abnormal cell growth, including cancerous changes. Many studies have shown that calorie restriction improves immune function in older animals, giving them protection against disease that normally comes with age. For humans, this means a more resilient immune system and a lower chance of experiencing the chronic illnesses that typically develop later in life. So, calorie restriction does more than simply reduce energy intake. It activates an ancient biological program designed to extend life and protect health during times of scarcity. The key to its power lies in autophagy, which turns aging from a steady decline into a more manageable process by constantly refreshing and repairing the body at the cellular level. By engaging this repair system, calorie restriction allows the body to function as though it were younger, cleaner, and more efficient, directly influencing the rate at which aging occurs when the body is put under calorie restriction. Something remarkable happens at the genetic and molecular level. It is not just about eating less food. It is about changing the way the body senses and responds to nutrients. This shift activates a network of longevity, related genes and pathways that act almost like master regulators of aging. Among the most studied are sirtuins, AMPP, and mTOR. These pathways essentially decide whether the body is going to prioritize growth and reproduction or switch gears into repair and protection. The balance between these two states plays a critical role in how quickly or slowly the body ages, and calorie restriction nudges this balance strongly toward preservation and maintenance. Sirtuins are a family of proteins that regulate DNA stability, inflammation, and mitochondrial function. Under conditions of calorie restriction, sirtuins become more active because they sense lower energy availability. Once activated, they help repair damaged DNA, reduce oxidative stress, and improve communication between the nucleus and the mitochondria. This communication is vital because as people age, the crosstalk between the nucleus and mitochondria tends to break down, leading to energy decline and increased cellular dysfunction. By enhancing this connection, sirtuins essentially make the body more efficient and resilient, slowing the wear and tear associated with aging. Researchers have also noted that sirtuins influence genes related to metabolism and stress resistance, which are critical for longevity. Another key player in this process is AMP, often referred to as the cellular energy sensor. When calories are restricted, AMPC gets activated because the cell senses that energy is limited. The job of AMPC is to restore balance by increasing energy production and decreasing energy-consuming processes that are not essential. This means boosting fat burning, improving insulin sensitivity, and enhancing mitochondrial biogenesis, the creation of new mitochondria. All of these processes are associated with better metabolic health and slower aging. In many ways, activating AMPK is like giving your cells a signal to stop wasting resources and instead focus on efficiency and renewal. On the flip side, calorie restriction also reduces the activity of mTOR, which stands for Mechanistic Target of Rapamycin. mTOR is a nutrient-sensing pathway that encourages growth and reproduction when food is abundant. While growth is necessary in youth and during times of recovery, excessive mTOR activation over time accelerates aging by promoting constant cell division and reducing repair. High mTOR activity has been linked to cancer, insulin resistance, and faster cellular aging. By lowering mTOR through calorie restriction, the body shifts into a state where it spends more energy repairing and protecting itself rather than constantly growing. This is why people who practice calorie restriction or intermittent fasting often see improvements in markers of aging and metabolic health. The interplay between these pathways creates a kind of internal switchboard that determines the pace of aging. When food and calories are abundant all the time, Sirtuins and Autophagy are quiet, while mTOR is loud, driving constant growth and storage. When calories are restricted, the opposite happens. Sirtuins and Autophagy turn on, mTOR quiets down, and the body enters a mode of preservation. This shift is not just theoretical. It has been demonstrated in a wide range of organisms, from yeast and worms to mice and primates. In nearly all cases, calorie restriction extends lifespan and improves health span, which means not only living longer, but living better. For humans, the practical implication is that constantly eating, snacking, and keeping insulin elevated prevents these longevity pathways from being engaged. Modern eating habits often mimic a perpetual state of abundance, with food available 24/7. This suppresses autophagy, weakens DNA repair, and accelerates the accumulation of damage. Calorie restriction, intermittent fasting, or simply giving the body longer breaks between meals reawakens these ancient survival pathways. In times of scarcity, the body was designed to protect itself, to conserve resources, and to strengthen its systems to ensure survival. That same mechanism can now be leveraged deliberately to slow the aging process. What makes these longevity genes and nutrient-sensing pathways so important is that they do not just affect one part of the body, they influence nearly every system. DNA repair protects against cancer, mitochondrial efficiency boosts energy, improved insulin sensitivity lowers the risk of diabetes, and reduced inflammation supports brain health. This wide-ranging effect is why calorie restriction has been called the most reliable intervention for extending lifespan in scientific studies. By turning on the right genes and turning down the ones that accelerate wear and tear, calorie restriction reshapes the trajectory of aging at the deepest biological level. One of the biggest challenges when talking about calorie restriction is the practicality of it. The idea of eating significantly fewer calories every single day for the rest of your life is not appealing or sustainable for most people. Constant hunger, fatigue, and the social difficulties of such a lifestyle make long-term calorie restriction nearly impossible outside of controlled studies. This is where intermittent fasting comes into the picture. Intermittent fasting provides a way to mimic the same benefits of calorie restriction without having to live in a constant state of deprivation. By simply narrowing your eating window or incorporating longer fasting periods, the body experiences the same stress signals as it would under calorie restriction, triggering many of the same protective pathways that slow aging and improve health. The key to why intermittent fasting works so well lies in the fact that it naturally lowers insulin and allows the body to spend more time in a fasted state. When insulin is low, the body shifts into fat-burning. Autophagy gets triggered, and longevity pathways like AMPP and sirtuins get activated. These changes do not require calorie counting, weighing food, or depriving yourself every day. Instead, the simple act of delaying the first meal, skipping snacks, or having longer breaks between eating gives your body time to repair and renew itself. This is why so many people find fasting easier to sustain than constant calorie restriction. You are not constantly cutting back. You are simply alternating between eating and resting your digestive system. Intermittent fasting also allows for flexibility, which is crucial for long-term success. There are different methods, such as the 16-8 approach, where you fast for 16 hours and eat in an 8-hour window, or the 1 meal a day approach, which compresses eating even further. Some people experiment with longer fasts of 24, 48, or even 72 hours, which can activate even deeper repair processes. The beauty of this approach is that you can adjust it to your lifestyle. If you have a busy day, fasting can simplify things because you are not worrying about preparing multiple meals. If you have a social event, you can shift your eating window without losing progress. This flexibility makes it far more sustainable than traditional calorie restriction, which demands strict adherence day after day. In addition to being practical, intermittent fasting may even provide unique benefits beyond calorie restriction. The rhythmic cycling between eating and fasting trains the body to become metabolically flexible. This means your cells can smoothly switch between burning glucose and burning fat for fuel, a skill that many people lose when they are constantly eating. Metabolic flexibility improves energy stability, mental clarity, and physical performance. It also reduces the risk of metabolic diseases like diabetes, obesity, and fatty liver disease, which are major accelerators of aging. Accelerators of aging. This metabolic training effect makes intermittent fasting not only a tool for longevity, but also for everyday health and vitality. Another reason intermittent fasting is so effective is because it aligns with how humans evolved. Our ancestors did not have constant access to food. Periods of fasting were a natural part of life, whether because of scarcity or because food had to be hunted or gathered. The body adapted to thrive under these conditions, developing survival mechanisms that get activated when food is absent. These mechanisms include improved repair, increased resilience, and sharper brain function, which would have been essential for finding the next meal. Today, by deliberately practicing intermittent fasting, we are re-engaging those same biological programs that helped our ancestors survive, but in our case, we are using them to age more slowly and maintain better health. People who practice intermittent fasting often report benefits that go beyond theory or lab studies. They notice increased energy, sharper mental focus, better digestion, reduced inflammation, and even improvements in skin health. These changes reflect what is happening at the cellular level. When the body is no longer burdened by constant digestion and high insulin, it can redirect energy into repair and renewal. In other words, intermittent fasting allows the body to do what it was designed to do, heal and maintain itself during periods without food. This is the same principle that makes calorie restriction effective, but it comes in a form that real people can actually follow. Ultimately, intermittent fasting proves that you do not need to starve yourself to slow aging. You just need to give your body more time in the fasted state where the repair pathways are turned on. This strategy provides the same anti-aging effects: activation of autophagy, improved mitochondrial health, reduced inflammation, better insulin sensitivity, and protection of DNA without the downsides of chronic deprivation. It offers a realistic and powerful way to harness the body's natural longevity mechanisms, while still allowing you to enjoy satisfying meals and live a normal life. When people hear about calorie restriction, the focus often falls on the number of calories rather than the quality of the food being consumed. This is one of the biggest misunderstandings about longevity and anti-aging nutrition. Simply cutting calories while still eating processed foods, refined sugars, and harmful oils will not deliver the benefits seen in scientific studies. In fact, it can do more harm than good because the body becomes deprived of essential nutrients while still being exposed to foods that accelerate aging. What really matters is nutrient density, meaning how many vitamins, minerals, antioxidants, and beneficial compounds you get per calorie. When calories are restricted, every bite counts even more because the body must rely on fewer resources to carry out repair, maintenance, and energy production. Nutrient-dense foods provide the raw materials the body needs to build enzymes, hormones, and protective molecules that defend against aging. For example, antioxidants from vegetables and low-sugar fruits help neutralize free radicals that damage DNA and accelerate cellular decline. Minerals like magnesium and potassium support mitochondrial function and cardiovascular health, both of which tend to deteriorate with age. Omega-3 fatty acids from fish and certain seeds provide structural support for cell membranes and reduce inflammation, another major driver of aging. When these nutrients are abundant, the body can perform at a higher level even with fewer calories. But if the diet lacks them, calorie restriction may simply speed up malnutrition, leading to fatigue, weakness, and accelerated aging rather than slowing it. One of the clearest examples of this principle can be seen when comparing whole foods to processed foods. A person could eat 1,500 calories of junk food per day and technically be practicing calorie restriction. But the lack of nutrients would leave their cells starved of what they need to repair and regenerate. Over time, this would weaken the immune system, disrupt hormone balance, and accelerate the breakdown of tissues. On the other hand, someone consuming 1,500 calories of nutrient-dense foods such as leafy greens, cruciferous vegetables, wild-caught fish, pasture-raised eggs, nuts, seeds, and healthy fats would be fueling their cells with everything needed to thrive. Even with fewer calories, their body would have the building blocks to maintain strong bones, healthy skin, sharp brain function, and efficient metabolism. Another layer to consider is how nutrient density influences satiety and cravings. Highly processed foods are low in micronutrients, but high in refined carbs and unhealthy fats, which leave the body unsatisfied. This often leads to overeating, making calorie restriction nearly impossible to sustain. In contrast, nutrient-dense foods naturally satisfy hunger because the body recognizes that it is getting what it needs. Foods rich in protein, fiber, and healthy fats keep blood sugar stable and reduce cravings, making it easier to practice intermittent fasting or reduce calorie intake without constant struggle. This highlights how nutrient density not only supports longevity at the cellular level, but also helps maintain the discipline needed to follow through with calorie restriction strategies. Nutrient-dense eating also directly supports the repair pathways that calorie restriction activates. For instance, autophagy requires amino acids and minerals to recycle old proteins into new, functional ones. DNA repair processes rely on compounds like folate, zinc, and polyphenols found in vegetables and herbs. Mitochondrial renewal depends on cofactors like B vitamins, iron, and CoQ10, which are abundant in foods like grass-fed meats and leafy greens. Without these nutrients, the body cannot fully take advantage of the benefits of calorie restriction, even if the calorie count is perfectly reduced. This is why studies in animals and humans consistently show that calorie restriction works best when the diet is also nutrient-rich rather than nutrient-poor. Another critical point is that nutrient density can buffer the body against stress. Calorie restriction is, in itself, a form of stress, and while mild stress can activate repair pathways, too much stress without the right nutrients leads to breakdown. Antioxidants, adaptogens, and phytonutrients found in colorful vegetables and herbs help the body adapt to this stress, ensuring that the positive effects of calorie restriction outweigh the negatives. Without them, the body may experience hormonal imbalances, lowered immunity, or faster muscle loss, which undermines the purpose of restricting calories in the first place. So the takeaway is that calorie restriction alone is not the magic bullet for slowing aging. It is calorie restriction paired with nutrient density that truly delivers the results seen in longevity research. The body needs high-quality fuel to activate autophagy, repair DNA, reduce inflammation, and maintain mitochondrial health. Nutrient-dense foods allow the body to thrive even on fewer calories by supplying the essential components of life itself. Eating less of the wrong foods weakens the body, but eating less of the right foods strengthens it, enabling calorie restriction to fulfill its role as a tool for longevity rather than a pathway to deficiency. One of the clearest reasons calorie restriction has been linked to slower aging is because it reduces the accumulation of cellular damage over time. Aging can be thought of as the gradual buildup of problems inside the body: oxidative stress, DNA mutations, damaged proteins, and chronic inflammation. Each of these contributes to the decline in energy, resilience, and repair that makes us age. Calorie restriction helps by dialing down the processes that create this damage while enhancing the mechanisms that clean it up. The result is not just fewer calories consumed, but a slower pace of internal wear and tear, which directly translates into a longer health span and, in many cases, a longer lifespan. Oxidative stress is one of the biggest drivers of aging. When mitochondria generate energy, they also produce free radicals as a byproduct. These unstable molecules can damage proteins, lipids, and DNA if not neutralized by antioxidants. In a state of constant overnutrition, mitochondria are pushed to work harder than necessary, producing excessive free radicals and overwhelming the body's defenses. Calorie restriction reduces the burden on mitochondria by lowering the overall energy demand, which in turn decreases free radical production. At the same time, it stimulates antioxidant defense systems, making the body more efficient at handling the free radicals that are produced. This twofold effect, less damage being created and better cleanup of what remains, protects cells from one of the primary causes of aging. Another important aspect is DNA integrity. Every day, DNA is under attack from free radicals, toxins, and even mistakes made during cell replication. Over time, these errors accumulate, leading to mutations that can drive aging and disease. Calorie restriction activates DNA repair pathways and stabilizes chromosomes, reducing the rate at which damage builds up. By lowering insulin and blood sugar levels, calorie restriction also reduces glycation, a process where sugar molecules stick to proteins and DNA, creating advanced glycation end products that accelerate aging. By keeping glucose and insulin in check, calorie restriction slows this damaging process and preserves the integrity of cellular machinery. Inflammation is another key factor in cellular aging. Chronic low-grade inflammation, often called inflammaging, drives tissue damage, accelerates diseases like arthritis, heart disease, and Alzheimer's, and disrupts the body's ability to repair itself. Instead of the gradual decline in energy that most people accept as normal aging, calorie restriction helps sustain higher energy output deep into later life. Mental clarity is another area where calorie restriction shines. By keeping energy steady, sharpening the mind, strengthening the immune system, protecting the heart, and maintaining mobility, calorie restriction allows people to not only extend their years, but to make those years worth living.